The frog, the amphibians, respire using three methods. So we're going to consider each of those methods. The first method is via the skin. Okay, the skin of the amphibian is very moist. If you've seen a frog before or a toad, you would see how moist the skin is. So that skin, for the fact that it's moist, is a good criteria. It's a good characteristic of a respiring surface. A surface that is used for respiration has to be moist. So what happens here is the oxygen in the air, okay, will dissolve on the moist skin and then diffuse in, while the carbon dioxide, the waste product, will diffuse out of the skin to the surrounding. Very simple diffusion occurs on the skin. Then the second method it uses is the buccal cavity. The buccal cavity is a space just within the throat of the frog. Okay, how does it get air to the buccal cavity? It allows air from the exterior. The air comes in through the nostril and goes in. So it keeps the mouth closed, it keeps the glottis closed, and it lets the floor of the buccal cavity, this is the floor here, it lets the floor down. Okay, once the floor comes down, it creates enough space so that air accumulates. Once air accumulates, it closes off the nostril and it allows the air to stay within the buccal cavity. And this buccal cavity is lined, there are plenty of cells on the wall of this buccal cavity, and these cells are lined with generous meshwork of capillary vessels. And so on the surface of the buccal cavity, there will be active diffusion of gases. Okay, the carbon dioxide will be given off while oxygen will be taken in within the buccal cavity. And once that has happened, what the amphibian will do is it will raise the floor of the buccal cavity so that the pressure here will remain much. The pressure within the buccal cavity will be much, and this will force the nostril, the flaps in the nostril, to open, and the air will be given off. Sometimes it also uses the lungs to respire. The lungs, the third method the amphibian uses is the lungs. Okay, just the same way it gets air into the buccal cavity, that's the same way it will get air. Once air is in the buccal cavity, it will close off the nostril, the mouth will be closed, it will increase the buccal, raise the floor of the buccal cavity. If it raises the floor, the buccal cavity will remain small now, right? Because the pressure will be increased, and then it has raised the floor, so the space within the buccal cavity will be smaller. So there will be force on the epiglottis here. Okay, and some air will be forced into the lungs. Also during this process, some air also will be forced out of the nostril, so it's not a very effective process. So once air gets into the lung, it gets to the alveoli, and within the alveoli there is gaseous exchange. Gaseous exchange takes place, oxygen gas and carbon dioxide goes out. Okay, once that happens, it will take the carbon dioxide that is made here, brings it back to the buccal cavity, and then it will be forced out of the nostril. The next vertebrate, a lower vertebrate we'll be looking at, is the fish, respiration in the fish. This drawing here is quite explanatory. What happens is water comes in, the fish opens the mouth. Once the fish opens the mouth in the water will enter through the mouth. The gill cover will remain closed so that the water that comes in does not go out. So once water enters the mouth, the water stays here within the mouth cavity. From there, as much more water is entering within the mouth cavity, it gets to the gill system. Within the gill system, the heart has already has vessels lining the gill system, and the blood in the vessels is flowing in opposite direction to the flow of water entering the gill system. Okay, so because of that, there will be gaseous exchange. Oxygen will go in, will transfuse into the blood vessels, and then the carbon dioxide at the blood vessels that is within the blood vessel will diffuse out into this place, okay, into the water that is already here. Okay, once that has happened, the fish will close its mouth. Once the fish closes its mouth, it will open the gill cover, okay, to expose the gill opening. So from the gill opening, the water that now contains carbon dioxide will be let out into the surrounding. It's as simple as that.